Hi, this is Billy. Yesterday, I posted a video about a variable inductance made using credit card. The two coils, when they overlap, will have the highest inductance, and when they are moved away, we have less inductance. Hence, we can use it for tuning. Let me hook it up to my inductance meter and show you the variance in inductance as I move the two coils to overlap or not overlap. So after further testing and turning it into a real FM crystal radio, this is the conventional MOSFET circuit that I always use with the MOSFET called 3DQ or 3SK-143Q. And this MOSFET is very sensitive to FM and AM, so it's very good to use for crystal radio. So for this crystal radio, the most important thing is this variometer. You see, I just use two coils, one at the bottom, around 1 turn. I drill some holes to mount the coil, the two terminals of the coil there. And then for the second terminal, I connected a thinner magnet wire to the second turn on the top of a movable plate. So these two coils are connected and wound in the same direction through a tiny magnet wire there. It needs to be small and soft and flexible so when I move it won't break. If you use too thick wire, it will either block your movement or it will break. You can try to see how thick a wire you can go without hindering the movement or breaking the wire after a few tuning. And so total there will be 2 turns. To take the tapping point for the MOSFET source pole, I use 1/4 of a turn of the first turn. I connected a 0.5 millimeter magnet wire to the source pole of the MOSFET here. And then it works like a detector or a diode, and the output will come from the drain, which is the third pin here. The drain will connect to my headphone jack. It's a conventional 3.5 millimeter hi-fi stereo headphone jack. The other terminal of the headphone jack will connect to the ground, which is also the gate 1 of the MOSFET. So gate 1 of the MOSFET connect to the ground and also connect to the cold end of the coil at the top here, which is the second turn. Okay. And between the hot end and the cold end of the coil, that is the bottom coil and the top coil, I connected a 8PF fixed capacitor to complete the resonance circuit. So these 2 turns, each of 22 millimeter, creates a coil that will resonance with this 8PF fixed capacitor. Right now I'm just using a ceramic fixed capacitor. The Q factor will be a bit lower, but I can try to buy those high Q SMD type fixed capacitor for the same capacitance. That will boost up the Q factor multiple times, and hopefully the reception will be better. The problem with this one is because the variometer can only vary the inductance from 0.06 microfarad to around 0.04 microfarad. You see in the video that I posted previously, right? That's roughly the range. And this range may not be enough to cover the full spectrum of the FM frequency range, depending on where you are located. In Hong Kong, it's between 88 megahertz to around 106 megahertz. So this variometer may not be able to cover that range. So If we want to cover the full range, maybe we need to connect with different type of fixed capacitor, 8 PF or 10 PF or even higher, to switch to different bands. However, if you start doing that and using a switch in between the fixed capacitor and the coil, then the resonance circuit's Q factor will deteriorate very rapidly. So I don't know whether I would do that. I'm continuing to look for other solution for variometer type FM crystal radio that can be used on a credit card. The other one we can try is like treating the coil like a spring that can squeeze and stretch. When you squeeze the coil, the inductance will increase because the wires are moving closer together in the neighborhood. If you stretch the coil, make it longer, the inductance will tend to decrease. So this may vary the inductance and can be used for a method of tuning. I've tried that before in my syringe type variable capacitor using a syringe that you use to take injection. It also have the similar problem of not able to cover the full FM frequency spectrum because the maximum and minimum inductance you can get from squeezing and stretching the FM coil is not fully covering the FM station. That's why I still do not have a solution. So let's see what we can get. But this is a good try, a good test of a variometer for FM. Okay, next we'll show you how I test it. And right now I can only tune to one station. Later on, maybe by changing the fixed capacitor to a higher Q factor, maybe I can tune in more stations. I'm using this small transformer. It's not active. It's a passive transformer to step down and match the impedance between the iPhone and my crystal radio, and also to isolate the DC current so there won't be any static during the recording. So let me hook it up and see whether I pick up anything. Let me hook up the antenna. Antenna will be connected to 1/4 of the turn on the first coil, and the other end will be connected to my Yagi antenna that I hang by my window over there. So there's no active components, everything is passive. This is a closer look of the detector, MOSFET 3DQ. This circuit will also work with a regular diode that can work in the FM frequency. This is the end of the testing. If you're interested, you can continue to watch a Chinese New Year flower market, a short video that I captured just today. Today is the Chinese New Year Eve. So happy Chinese New Year of the Year of Dragon to everyone. Thank you. Hey everyone, this is Billy. Today is the Chinese New Year Eve and I'm walking by one of the flower markets for the Chinese New Year. Let me take some video and share it with you.
5蚊2位，唔該唔該，我中意呢個。咁海風又係做床嘅。大皮賣嚟緊啊！你每日買一支咪得咯。你交自己抽咯。你有冇玩人？我下次揾佢。40蚊湯，20蚊紙啊！ 任你揀啊！
我驚到。
喂，呢度幾呢度焦啲嘅奶啊，嗰隻仔咁，呢隻奶。
佢呢個好快謝嘅啫喎，插㗎。
邊區出發嚟㗎？
揀啊，100蚊4紮，隨便揀啊
100蚊4紮，大紮，攞上手擦下佢。
如果講包最正好大啊！呢隻都係頭髮。哦。
點解我哋要仲可能要改出去嗰度？要紅色嘅嘢。呢個係咪呢個顏色？洗頭嗰啲咯。
我隻啊。
冇啊，係啊。
老北京啊！
你家嚟咁我就唔睇佢咯。
奧製揮春喎。
哇！點解開始熱嘅？唉，唔使啦，生意正。
你一隻火龍果會冇拍過，呢個我要乜？呢條唔好整爆佢啊！